module. Release when it gets live on YouTube.
It is. Should be. All right. Hi.
Is there a way to push the TV up?
Good question.
It's hard to see.
I don't think so. No, sorry. Without unscrewing it.
Are you sure we're live? Check mine off at YouTube. That's unfortunately it. Hi. Was it less than 4?
All right. Yes. Good evening. Again, apologies that we're in this very crowded little room. Not our choice. We just go where we're put. So thank you all for crowding in. I got some new faces here tonight. Who's here for the first time? Second time. Yeah. So as Ollie said, you've joined us at the end of our second little 5-week module. So the way we do this course is that we divide it up into sort of reasonably self-contained modules about a particular subject. So the first one was really the introduction to C++. We called it Initial C++. And then this is our second module all about writing custom types. So if this is your very first time here, it may, unless you have done some C++ or perhaps some Java or something similar before, you may find this is all a bit like, whoa, this is scary. Don't be scared. All of our previous slides for all the previous sessions and the videos are all available. So if you want to go through those, you can go to our YouTube channel. So youtube.com/CPP London Uni has got all the videos from all our previous sessions, and our GitHub page, which I'll put the link in at the end. It's also available on our website. I've just found out. That has all the slides from all our previous sessions as well. So if you want to go and catch up, that'd be awesome. Yes. Otherwise, today, if you feel it's all a bit like, this is terrifying, don't worry. Everyone was in the same boat, and they're really happy now, aren't you? Everybody else. Yeah. You think it's awesome. And I say this every week, but we'll do it one more time. We have this chat room on Slack. So Slack is a chat application used a lot in programming circles. There's a CPP Lang Slack channel. So for discussing the C++ language, it's got a couple of thousand members on there. But in particular, we've got our own chat room. So this is technically invitation only, but it's a very exclusive club. All you have to do is go to that URL and put your email address in, and it'll send you a link so you can join. So do that, and you can talk to us, you can talk to each other, and it'll be great. Okay, oh no, there's one other thing I have to say, just for the last time, in fact. Yes, Oliver has been growing some wonderful facial hair, as you can tell. It's very, very impressive. Freddie Mercury in the corner. It's for Movember, of course, and if you'd like to support him in looking like a fool for November, then you can go to this URL, mobro.com/OliverCPP, and give generously. It's all for charity, good causes. Please go and do it. Right. That's all the notices out of the way. Let's go on to talking about C++. So last week we were talking mostly about constructors. Well, entirely about constructors. We had a sort of introduction to what constructors are, destructors, how we call constructors, and we had all that horrible stuff about different syntaxes, what the differences between the curly braces and the round brackets. And we talked about writing constructors. So what a constructor looks like, how we go about writing one. And we talked about member initializer lists. So if you remember, the member initializer list goes on the definition of a constructor, and we write the colon, and then we write the member name, and then the initializer. So that was last week. This week, I'm just going to finish off something we didn't quite have time for last week, which is to talk about explicit constructors, and then we're going to go on to talk about the main thing for this week, which is public and private member access. And then finally, there's this little sort of questionnaire at the end, just to find out how well I've taught all you guys. So hopefully I come out of it well. Yes.
Question based on last week's lecture. I was going to ask about sort of I was going through it online and based on so if a struct or a class it's not an aggregate, it's
Yes.
an aggregate, so it's got a constructor.
Yes.
But it doesn't have a default. It has member variables with default values
Yes.
defined.
Yeah.
And it has a constructor as well.
Yes.
But it's not a default constructor, it's just a general
Yes.
purpose constructor.
Yeah.
For that, do you need to then create or initialize a default constructor for that class to construct properly?
So the
What's the rule, let's say?
okay. So the default constructor is a constructor that takes no arguments.
Yes.
So in general, you want to give your class a default constructor if there is some sort of meaningful default value, some sort of meaningful value. So for a string, for example, a meaningful default value would be an empty string. For something that behaves like a number, a reasonable default value might be 0. Right. Not all classes have. A vector as well has a default constructor that just constructs an empty vector with nothing in it. So in a lot of cases, yes, there is a sort of meaningful default, and it's reasonable to provide it. But not all classes, not all structs have a sort of meaningful default. And in that case, it's fine. You don't have to provide a default constructor. You said you have the default member initializers, so the ones that go on the
Yes.
at the end of.
And there is a constructor and also a constructor, but it's
Yes.
not a default constructor,
No.
it's just
Yeah.
standard.
So in that case, anything you don't mention in the member initializer list of that constructor, it will just use the default member initializer.
Okay. Yeah.
So whether you supply a default constructor or not is sort of a design issue. There's no kind of hard and fast rule as to whether you
But
should
then you
provide
can't
it.
then declare outside of using that class or struct. You couldn't create an instance and not call a value or a constructor.
Correct. Once
Then you
you've
need
given
to
it a
define
constructor,
default.
once you've given it a constructor, the only way of initializing that is via a constructor. So the aggregate initialization, that sort of member-wise
Yeah,
initialization, that only applies to this special
Yes.
case of structs that have no the terminology is user-defined constructor.
Right. So the only way then you would be able to do that is through a constructor with a member initializations,
Yes.
or by having a default constructor which can initialize. certain
Absolutely,
variables.
yes.
So you basically need a default. In that example, you can also have a default constructor to initialize to override the member.
Yes, yeah, absolutely. Okay, so I gave you some, well, it wasn't really homework so much as it was an exercise that we had in class that we didn't really have time to finish. A lot of people were still working on it, but we had to move on and cover more stuff. So it was all last week. Oh, is this the right one?
No,
That's the week before. Ah, that's annoying. I've left the wrong one on my slides. Okay, well, I'm going to have to change that now. So. Do apologise.
Hi guys, sorry we are late.
No worries.
Oh well, this is going to be a squeeze. Yes.
Shall I go and ask for some seats?
Oh,
Yeah, there are two more chairs there. Well, while we're getting rearranged, I'll see if I can find the homework for last week. Sorry.
push those out.
Move our table, they can sit here. Not just out. We just open up here.
They might be able to move all the desks up and create space at the back.
Sorry, they're not choosing.
No, the other way.
So they, once they
I
find
thought
the
you
chairs,
said this one. Yeah, but they're not using it.
No, thank you very much.
once they find the seat and the chairs, nothing
People
goes
sitting
there.
there.
I thought that was
We
it.
can make the squeeze it a bit.
Sorry, screen, sorry.
No, oh, no.
We're moving everyone up, so there's space
Yeah.
at the back, so probably you can sit.
They,
Yeah,
It's not-
it's
it's
not-
not-
it's on the same.
okay, okay, okay.
Sorry.
Yeah, yeah, if no one is sitting here, I will help.
Oh, it's still fine.
That's fine, you want to go.
Okay.
No.
John, if you split the table, they can sit in the middle. Well,
Right, this was the homework that I gave, well, the exercise we were doing last week. I haven't formatted very well because I've just copied and pasted it, but it's very small on this TV, I do apologise. I thought we were going to have the nice big projector again this week, so if you're, yeah, you're fine. But for everybody else, it might be a little bit small, but basically, I wanted you to have an exercise of writing constructors. So we've been using at various points in this module point, the struct that has two integer x and y coordinates, and then I wanted you to write a line class of struct. So a line just connects 2 points. So I wanted you to write a constructor for your class line, a default constructor, and then, what did I ask you to do after that? To experiment with the equals default and equals delete commands to either default construct or to define a constructor as deleted. So the solutions are available at this URL, which has actually come out nice and large. So the week 13, don't worry about that. That was a past version of the course. I've just recycled the exercises. But if you want to go and have a look at my solutions, you can go to this URL. If anybody had any problems with it, I can quickly go over it now, but we're not going to have all that much time tonight, so I'd kind of rather move on. And if people want to have a look at that, and then you can go on Slack and ask if there are any problems. I think probably the best way of doing it. That's okay? Cool. All right. I haven't really given you a chance to ask to have a good look at it, but if there were any questions, if anybody did it, now is the time to speak up if there's anything you desperately want to ask me.
Just
Yes.
looking at it right now, on point CPP file,
Yes.
I'm just not seeing these operators style things. Is that kind of...
Yes, so we covered, so is this your first time?
Here's my first
It
time,
is,
yes.
welcome.
Hello.
Hi. I did do a general, because we've got several new people tonight actually.
Yeah.
So I'd said this a few minutes ago. So yeah, we're at the end of our second module now. So you've joined, yeah. If you haven't seen any C++, this might be a bit like, whoa.
a little bit.
Yeah, so that was reference to operator overloading, which we covered 2 weeks ago.
Right.
So all my slides are online on our GitHub page, so github.com/cpplondonuni.
Mm-hmm.
And the videos for these sessions, which is me talking along with the slides, all those are on YouTube as well. So if you want to go and catch up, you can go to youtube.com/cpplondonuni, and there's a massive list of all our past videos.
Awesome. Thank you.
Okay, so what we didn't have time for last week was talking about explicit constructors. So we discussed constructors. You can have multiple constructors. You can have constructors which take no arguments. It's a default constructor. You can have a constructor that takes many arguments. Like ordinary member functions, you can give them as many arguments as you like, as many parameters as you like. Constructors which take a single parameter are kind of special. They can be used for what's called an implicit conversion. And this is where the constructor gets called kind of in a sort of hidden way and automatically by the compiler. So here we've got a struct example, and I've given a constructor which takes an int. And now I've got a function, free function, which takes a const reference to an example. So in order to call this function, we have to pass it an instance of an example. But this is perfectly legal. We can call func, which expects an example. We can just pass it 3. We can pass it an int. And what's happening here is that when we call func, it's saying, okay, well, it looks at all the overloads of func. We've only got one. And it says, okay, this function takes an example. Now, I've been given an int. Is there any way I can convert this int into an example in order to call this function? And it says, oh, well, yes, I can, because I've got this constructor that takes one argument. And this is what's called an implicit conversion. And it's implicit because, you see, in this function call here, we don't actually mention the type example at all. There are other sorts of implicit conversions. They often happen between numeric types. For example, you can get an implicit conversion between a float and an int, for example. But it also happens with these single argument constructors. But implicit conversions are generally regarded as a bad thing. Here we might have expected that we were calling a function that it's surprising that we should be able to just pass an int to that function when it was expecting an example. Implicit conversions are a sort of shortcut through our type safety and generally not regarded as being a very good thing. Sometimes they can be useful, but most of the time implicit conversions are not what we want. So to avoid that, to avoid a single argument constructor being used as an implicit conversion, we can use this special keyword explicit. So if we have a single argument constructor, well, you can put it in front of any constructor, but it only really has an effect with single argument constructors. We write the word explicit in front of the constructor declaration, and that prevents it from being used as an implicit conversion. So it's really good to get into the habit of whenever you have a single constructor, a single argument constructor, to put this word explicit in front of it. It's just get into the habit of making things explicit by default, and then in certain limited circumstances when it's useful, you can get rid of that word if you actually want the implicit conversion.
If you pass it a double, would it convert it to an int?
Yes, I think it would. Yeah.
So you lose precision. Would you think you'd get a warning?
You probably would get a warning, yeah. So here we've got struct example again, and this time I've written explicit in front of the constructor. So exactly what we had before, except I've added this explicit keyword. And then we have the same function again, just takes an example. And this time, when I try and pass 3 directly to this function, it's a compile error. It says, this function is expecting an example, and you've given me an int. That's what we want. We want this type safety.
Question.
Yes.
Say for example, you had in this case int I comma int j.
Yep.
And sorry, let me rephrase my question. say you had a double parameter constructor without explicit.
Yep.
And you had the same thing, except you had const example E, const example F.
Yep.
And then you said func 3, 4.
That would not work, no. Oh, wait.
Without
If you had the constructor that took 2 arguments,
Correct.
no, that wouldn't work.
Okay.
So if func took example E, example F,
Yeah.
and you just had this constructor,
No, sorry, you had an int ij, so you had a double argument constructor.
Yeah.
The same rules apply explicitly.
no. Only single argument constructors are used for implicit conversions. It doesn't go, oh, well, you've given me 2 arguments, but I could sort of do a conversion and call this function that takes 1 argument. That doesn't work.
Because obviously, as far as it's concerned, you're basically passing 2 arguments to func.
Right.
But func only takes 1 argument.
No,
which
let's
is
say
fine.
let's assume func did take 2 arguments.
Yeah.
Right? And you had.
Yeah.
But you had. Imagine this whole example just with 2 arguments.
Yeah.
You're saying that
There would be no implicit conversion even if I didn't use this one.
Well, if you didn't use explicit, but func took an example and an int, and you did 5.5, it would still do the implicit conversion of example.
But not if the example constructor took 2 arguments.
Yes, precisely. Once the constructor takes more than 1 argument, that's impossible.
Yeah.
You can only forward 1 argument.
Implicit conversions only happen with a constructor that takes 1 argument, or a constructor that can take 1 argument.
If you override, say if you have a func with 2 arguments, but you have a constructor, or you have a constructor with 1 argument, you don't need to put explicit in the 2 argument one, but you put explicit in the 1 argument.
Correct. Yeah.
You can forward it.
Because even though you've depending on what many
So, having made this constructor explicit, it's no longer a candidate for an implicit conversion. So trying to pass 3 directly here, it's going to be a compile error. It's going to say, well, I was expecting an example object, you've given me an int, that's not going to work.
Yeah, so my question was ill-formed. What I meant was, you obviously don't change the number of arguments to this guy.
Yes,
But you do have that double, that would still just do the implicit conversion twice.
yes, for both, implicit
Yeah,
conversion
sorry.
for both arguments. I see what you mean, yes. But not if we put the word explicit in there.
Okay, just one more annoying question. Why, if you have... No, I see, right, because it's in this case, it's a single argument. I can see why it's implicit now. It only applies to the single argument case. Right.
So if we do want to call func, we have to do it like this. We have to construct an example and call the constructor. We'll pass the constructor 3. So in this case, we're explicitly constructing an instance of example to pass it to this function. So this is happening explicitly. That's what the explicit keyword means. We are required to call this constructor explicitly. So the second case, in general, is better. It's usually what you want. Right? So just get into the habit, anytime you write a constructor which can take 1 argument, put the word explicit in front of it. It's usually what you want. There is one slight wrinkle, well, not wrinkle, but something to be aware of, is that constructors, like all other functions in C++, we can have default arguments, default parameters. So you write the parameter type, name, and then equals some default value. And in that case, if it's got a default value, it can be called with 1 argument. So if you had, example brackets, int I, int j equals 3, that is a constructor which can be called with 1 argument, and so it would be a candidate for implicit conversion.
Oh, wait, can we call a function like int I equals 3? Inside the function, can you call a function with this parameter?
You could say int, so
Function.
func brackets int I equals 3.
Oh,
That's a function which can be called with either 0 arguments or with 1 argument. And if you call it with 0 arguments, then inside the body of the function, I will have the value 3. It's a default parameter, which yeah.
sorry.
It can be any function, not the constructor only.
And no, any function can have default parameters. Member functions, free functions, constructors, anything which takes arguments can have a default argument. You have to. Did I cover this? I'm sure I covered this a few weeks ago when we were talking about first talking about functions. But you have to start putting your default parameters in from the right. So the last. You can't have a function which does not take a default parameter after one which does take a default parameter. So this is what I have to say on default constructors. On explicit constructors. It was just a little sort of 10-15 minutes that we didn't quite have time for last week. So I thought I'd slot it in at the beginning today. And the real takeaway from it, if you haven't understood anything else, is whenever you write a constructor that takes one parameter, put the word explicit in front of it. That's the takeaway. Any more questions about explicits before we get on to what I really want to be talking about today?
I was just thinking, under the hood, does it actually parses or instantiates when you do the func3 version? Like without instantiating, you're giving the integer value.
You're implicitly instantiating.
Yes.
So does it parses in those scenarios?
It creates a real instance of that object.
Oh.
It will have whatever lifetime. So in the case of the function, its lifetime will be the body of the function. But yes, there's a real object in the function because the function has to work on the object. The compiler is saying, "Oh, this argument is compatible. Let's just create the object the function wants from that argument." The free that you use, right, is trying to be helpful. And then as far as the function knows, it's just got an instance of that object. But yes, there is a real object.
Cool. Okay. Let's talk about public and private member access, or member access in general. So we'll start off thinking about a problem. Let's imagine we want to use a string which we guarantee is always going to be lowercase. So how can we do this? Well, this is C++, we like types, we like type safety. We'll create a new type which contains a standard string as a member, wraps a standard string, but it guarantees that this string that it contains is always lowercase, right? So we can do that in the constructor. The constructor takes a string, we save that string, convert it to lowercase, and store the lowercase version. So we can do this work, do the conversion to lowercase in our constructor, and that way we can guarantee that whenever we have a stored string, right, our lowercase string always stores the letters in their lower form. So this is great. The type safety rules, C++ is, well, mostly a type safe language. And it means that we can guarantee that we'll never be able to mix up our nice lowercase string with the more general standard string. So we can write our own lowercase string class that just wraps a standard string, but guarantees that it only holds little letters. So have a quick look at how we might do that. So I've called it LCString. And I've written a constructor that takes a reference to a general string. Notice it takes a single argument, so I've made the constructor explicit. It'll pop up in a minute, but I've got a member variable of type standard string called str, so this is using the member initializer list. Remember from last week? Yeah.
I'm sorry to interrupt. Is there any chance for you to just make it slightly bigger? Is there like when using a Mac, there's an accessibility option to zoom that follows your cursor, if you know what I mean?
Ooh,
Can we
I
follow?
apologize,
Can
I
we
really
follow?
can't see very much.
Yeah, you could go on YouTube.
Is it there? Okay.
might be an easier way of doing it,
Yeah, never mind.
because I don't know with Keynote whether that would work.
It does, but it doesn't matter. If you got it on YouTube, that's fine.
Yeah, it's
Yeah.
like
It's a few seconds behind, and you might get a funny echo with
Never
me.
mind.
But,
You can turn the volume.
Yeah, mute the volume.
so I've used the member initializer list to construct our str, our string member that you'll see in a moment from this string s. And then inside the body of the constructor, I loop over every character in our stored string, and I replace it with its lowercase version. So this standard toLower is a function that's part of the C++ standard library, the C standard library, in fact. And it just replaces a character with its lowercase version.
I have a question.
Yes?
So I used the toLower function today.
Yeah.
But I didn't know it was from standard, but it still worked out.
Yeah,
It's
so
the same
yeah, toLower is it's part of the C standard library, so it's available with or without STD. You don't actually have to put the STD in there, but it's good practice to do it in C++ anyway. But because it's a C function, you can omit that as well. So this is our constructor. As I say, first of all, we store a copy of the string, and then in the body of our constructor, we loop over every character and replace every character with its lowercase version if it's a capital. For things that aren't capital letters, for numbers, punctuation, letters that are already lowercase, this function does nothing. It just returns the input. So then just to make our class usable, I have this function getString, which returns a const reference to the string that we hold. Notice this function, it doesn't modify our stored string in any way, so it's read only, so we declare this function as const. We put this trailing const at the end. I might be mentioning these things as a sort of form of revision, by the way, just for the fun questionnaire that's coming up later. So. I've also written a setString function. So we probably want a way to modify the string, to modify our lowercase string. So if somebody gives us another string and we want to change it, well, we've got to do the same thing again. They might have given us a string full of capitals, so we have to go through again. First of all, we store the new string they've given us, and then again we loop over it and we change every character to its lowercase version.
Can we do that if it's a constant?
No, this function is read only. This function is not. So this function is not marked as const. So you couldn't call this function on a const LCString.
Quick question. So the second function.
This one.
Yeah, this one. So that's returning a const string, reference to a const string.
Yes.
Okay.
Yeah, so it's got const at either end. This first one is part of the return type.
Yeah.
This second one refers to
The actual instance of that class.
exactly that, yes. And then we've got our standard string member, str, which we've used in various places. So this class has, or this struct, we have a constructor, we have two other member functions, and then we've got one data member. So does that look good?
Missed the semicolon.
I missed a semicolon.
The struct by itself.
So
Where?
Struct? No, it's all
It's
member
there.
of the struct.
Yeah.
Oh.
Just to go back to that const function again, double const a bit. So is the end const stopping the str from changing?
Exactly that, yeah. So
making sure that that's
this end const means that this is a read-only function. So if we have an instance, if we have a const LCString object, we can only call these read-only functions, only call the const member functions. So it means effectively that within a const instance of this struct, all of its members are const as well.
So, quick questions based on, it's good that this is on the screen now.
Yeah.
This is what I was referring to just right at the start. So here you have a member variable,
Yep.
str, and you have a couple of constructors going on, and member functions and whatever. And so here, would you, from externally, so from in like the main function, if you created a object called LCString and gave it and just said LC's object type LCString A,
Mhm.
and left it at that, you didn't pass any arguments or whatever.
That would not work.
Yes,
Because-
you would need a default.
A default constructor. Now, for this class, it would be reasonable to have a default constructor, and I thought about it, and I just didn't want to take up space on the slide. But An empty
So-
string is lowercase, so that would be fine to have a default constructor here, in my opinion.
Right. So in this case, would you need to have defined a default constructor inside this struct or no?
You would. So we've written our own constructor here, so
Yeah.
we don't get a default constructor.
Yes. So you would have to.
I'd have to write LCString empty brackets equals default
Yeah.
semicolon.
Sure.
I didn't want to take up any more space on the slide because it's already quite small.
And so if there was default initializers in there, let's say
Yeah.
it was in a string, it was int
Yeah,
or whatever,
yeah.
and you had default initialized them to like 0, 0 or whatever,
Yeah.
would you then still need a default constructor or no?
You do still need the default constructor, yes.
Okay. Well, I thought you had defaulted it, so you now knows that maybe just revert to that because you haven't provided anything else. So say you had said LC string A and provided no arguments or anything, because you've got defaults in there, initializations.
No, only for aggregates does that work.
Okay.
Not for a class with constructors. Once you've written your own constructor, you don't get a default constructor unless you explicitly provide one yourself.
Sure. Okay.
Or request it.
The language assumes you don't want it. It assumes that you only want ever to be able to create one through your constructor.
Right.
If you do happen to
So
want
then
it,
you must
create-
revert to member initialization lists before you call this
No, you
constructor,
could-
or you can do default constructors.
No,
and
you
so
could
on.
no. This could have declare a default constructor and just do equals default.
Yeah.
As long as all of the fields, so in this case the string at the bottom is also default constructable. So you can just turn it back on with equals default.
Yeah.
The point is you have to turn it back on because that's a safer default to have. You have to explicitly turn it back on.
Okay, thank you.
And there's a good reason for this that I'll come to in a minute, actually. We've got a problem with this, though. So that class that I just had on the board, on the screen, has a problem. Can anybody think what that problem might be? Knowing what you know about structs from the previous few lessons.
All the initializers public,
It's nothing to do with the initializer. Oh, well.
but the members are all public.
Yeah, well, there might be a clue to that on the top of the screen. Yes, indeed. Our
The
S.
string was initialized at the very end of this method.
Sorry.
The string was initialized at the very end.
No, it wasn't. The string gets initialized in the constructor.
It's private though, not public.
No, it's struct, so it defaults to public. So our str member is public. Anybody can access our str member and set it directly. So here we've got a little example of using our LC string. So we create an instance of LC string. I've called it hello and I've filled it, or I've called the constructor with a string full of capital letters. But when I print it, because the constructor has converted it to lowercase, this just prints hello in lowercase, which is exactly what we want.
Should that say hello?
Oh yes, it should, sorry. 2 seconds. Glad somebody's checking this. So we call the get string member function, we pass it to cout, and it prints hello in lowercase, because in our constructor we've converted this shouty string that we were given into nice, calming lowercase letters. Unfortunately, our str member is public, so we can just go and set it directly to the shouty string again.
Oh.
And now when I print get string, it's going to print hello in capital letters. So our guarantee that this is a lowercase string has been completely thrown away, because there's nothing to stop anybody going in and just changing this string that we hold to something new.
Violating your data.
Violating your data, indeed. Indeed. So we can say that our LC string class, our lowercase string, has an invariant. It's the terminology that's used. And the invariant in this case is that the contained string is always in lowercase form. And the unrestricted member access, the fact that you can just go in and set .str to whatever you like, it allows users to violate that invariant. And that's not a great thing, because if your other member functions rely on this invariant, then they're going to be broken if somebody comes along and starts messing about with your internal data members. This is bad. This is a bad thing. Fortunately, C++ has this functionality that allows us to declare that certain struct members are private. That means that nobody else is allowed to access them, read them, write to them, change them, look at them, do anything with them. Private members of a struct may only be accessed by other members of the same struct, or the same type, I should say. This means that if we make our str member variable private, only our own member functions can change it. So let's see what this would look like. It's come out even smaller, sorry about that. I know I was expecting, as I say, a nice big wall-sized projector, but I've only got this little TV tonight. Honestly, I think I've got a bigger one, bigger TV than this in my house. But anyway, the constructor is the same. Our getString and setString are the same. But now we've introduced this new word here. So private followed by a colon says that anything that follows this is private to our class. And I followed it with a declaration of our member variable, str. So now str is private to our LC string. It means nobody else is allowed to go and mess with it. So if we have main as we did before, we first create an instance and then we try and access hello.str, we're going to get a hard compile error. The compiler is going to say, no, this is private, you're not allowed to touch it. However, within our own member functions, it's fine. We can mess about with it however we like. So within the body of this member function, we can change str, that's fine, because it belongs to us. It's private to us. It's ours. But outside of that, say in the main function or in any other function or in any other class member function, wherever it may be, outside of the member functions of this class, we can't touch str. We can't read from it, we can't write to it. So if you're used to Java or C#, the idea of private fields is pretty much exactly the same as it works in C++. The syntax is slightly different. In C++, you write the word private followed by a colon and then list all of your private members, whereas in Java you put it in front of every field. But the idea is generally, well, it is exactly the same.
Are there only two of those things, public and private?
No, there's protected as well.
I was going to say, and then there's one that has none. Because Java has the one that doesn't clear anything.
No, there are only three.
Yeah, Java has package private, I think you're thinking of.
No.
Java's got private, protected, public. There's only three declarations. You can leave it off and then it becomes package.
Yeah, C# has internal as well. Anyway. So this is the idea behind private member variables. So it allows us to maintain our class invariants. So we establish the invariant in our constructor. In our member variables, we make sure that these invariants hold. And by making our member data private, it means that nobody else can come along and mess with our data. They can only access it, modify it via our public member functions, which we write carefully to make sure we always maintain our invariants. And in this case, the invariant is that the stored string is always in this lowercase form.
one question though. You're saying you're declaring this std string private in the structure.
Yes.
Then why do you need to on your constructor? Why do you need to then initialize? Like you have that colon str.
Okay, this is what's called the member initializer list for the constructor. So this is saying when you initially create this member, I want you to create it from the string that we were given. So this is nothing to do with private or anything like that. This just initializes our member.
Makes sense.
So private is what's called an access specifier in the sort of C++ terminology. And we can use it to designate which members of our struct are private. So after we've put the word private followed by a colon, we can list however many member variables we like, and all of those will be private to our type. So as I say, Java, C# have very similar idea, except you write private in front of each one. In C++, you just put private colon, and then you list them all.
So could you put actual functions in the private stores as well?
You absolutely
Which
can.
can be called internally.
I'll talk about that in about 2 minutes. So as you might have guessed from the title of the slide, there is a corresponding public access specifier. So you write public colon, list all your public members, private colon, list all your private members. And I just mentioned it, there's a third access level as well, third access specifier, it's protected. That's to do with inheritance, derived classes, the things that can be accessed by derived classes. We're not going to talk about that today, but just be aware that there is a third one as well. But today we're only talking about public and private because they're the most useful. We can interleave public and private in any way we like. You can have public, private, 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 protected, public. Just do it any way you like. The language doesn't care. It's most common to list all your public things first and then to list the private things, but the language itself doesn't care. You can mix and match these as you like. So for example, here we've got int I, which is public, and then in our private section we've declared a float f, a double d, and now we have more public things. We've created a public section. And if we wanted to, we could have some more private things and some more public things. We can mix and match them in any way we like. So create an instance of this. As I say, I is public, so we can access it, we can change it, that's fine. str, this time this member is in the public section, so that's fine. But if we try and access f, well, f is in the private section of our struct, so that's an error. This is not going to compile. The compiler is going to say, this thing's private, you can't change it.
Nor can you read it.
Nor can you read it, absolutely.
See, if you write private, you don't need to specifically say public in structs, right? Or do you need to do both?
In structs,
both examples?
you only have to use public after you've declared something private. So once you've said private, everything that follows is private until we get to the next public, or till we get to the next access specifier.
Or you can just group them.
Or you can group them, that's usually a better way of doing it.
So you wouldn't put public on top, just when you open struct.
You can do, there's no harm in doing it, but for structs you don't need to, because for structs by default everything is public.
In class it is.
Yeah, we'll talk about that in a minute as well.
What's the question?
So, that was for member variables. As Sarah pointed out, we can declare member functions as being private as well. Private member functions can only be called by other member functions of our class. So, for example, in our LCString, we were doing that lowercasing twice. We were doing it once in the constructor and once in the setString function. Now it might be good to, instead of repeating the same code twice, to put it in a function. code reuse and all that. But that function isn't of any use, shouldn't be made public. It's an implementation detail of our class. Right? There's no need for any of our users to even know that that function exists. It's completely for our own internal use. It's private to the implementation of LCString. So a little look at what quick look at what that looks like. These are even small. We just as I say, I should have prepared for.
Are these slides on the thing?
They're not on GitHub yet, but if you want to go to it's youtube.com/CPP London Uni, and you'll be able to see exactly this, but on the screen. So now in the constructor, I'm calling this new function make lowercase. Get string is as it was before. Set string. First of all, we're going to change our internal str, and then we're going to call the make lowercase function. And now in the private section of our class, we've declared this private member function. It's called make lowercase. And we just do what we did before. We loop through the string, change every character to its lowercase version. So this is a private member function because it exists in the private section of our struct. And just as before, the str member is private as well because it's still in the private section there. And so, just as before, if we try and explicitly call this make lowercase function, I got it right this time, hello. If we try and call this function, the compiler, there's going to be a compiler error. It's going to say, no, this function is private, you're not allowed to access it. But within our own member functions, within setString, within the constructor, it's fine, because it's ours, it belongs to us. We can call it. But outside of this class, outside of this struct, we're not allowed to access it. We're not allowed to call it. That will make sense. Awesome.
Can it kind of like allows you to like, if I know it's a bit weird, that like say you're looking in through a window.
Yeah.
The only things you will be able to see, the things that are clear public, the things are private hidden.
Yeah, that's a good way of thinking about it. Yeah.
Too many fortune cookies.
So in structs, we can have public things, we can have private things, we can have protected things as well, but we don't worry about them yet. And we can interleave these public and private things as we like. But I've already done it several times today, and people who've been here before will have noticed I've done it several times already in previous classes. I tend to mix up the words class and struct a lot. And there's a reason for that. It's because in C++, the words class and struct do almost exactly the same thing. And they're both used to declare what's called a class type. So even if you use the word struct, as far as the C++ language is concerned, what you're creating is a new class type, even though you've used the struct keyword. So there are only two differences between what struct and class mean in C++. And that's in their defaults. So anything you can do with a class, you can do with a struct and vice versa. Yes?
President, I've seen a code that there's a class, there's a struct inside.
Yes. That's called a nested class or a nested struct. So it's legal to declare a class inside another class. Yes. I didn't kind of want to go into it too much in this kind of fairly early stage of the course, but yes. And you can even make those nested structs private if you want, so that only you are allowed to create instances of them.
Is that like a helper class?
Usually, yeah. Yeah, usually it'll be of some internal use to you. Yeah. As I say, it's possible. Yes, you can have member types as well as member functions and member variables. I just didn't want to go into it too much, too early.
I'm going to forget that question. I'm going to forget what I was going to say. That.
Yeah.
That's what you said.
So the only difference between class and struct are their defaults. Wherever you use a class, you can use a struct. Wherever you use a struct, you can use a class. The only difference are the defaults. So the most notable, the one everybody can quote, the difference between class and struct in C++ is that structs default to public member access. So if you don't put an access specifier, everything in your struct is public. If you don't put an access specifier, everything in your class is private. That's the main and most important detail difference between struct and class. There is one other little difference that's less important or comes up less often. But because we can write access specifiers whenever we like, we can just override that default. So if you write class blah and immediately put public with a colon, that's basically exactly the same as writing struct blah. There's no difference as far as the language is concerned. And yes, if you're curious, I mentioned there were two differences. The other one is in the default kind of inheritance. So there's something in C++ called private inheritance. Classes default to private inheritance. But again, not going to go into that too much today.
When we define, if we declare and define in header and do we have to specify then, for example, column, whatever it is, do we have to say private or public, or it doesn't matter?
I'm not sure I thought what you say.
HTTP.
Oh, so when you're writing the definitions of
Yeah.
your functions,
Yeah.
if you write the definitions separately,
Yeah.
no, you don't have to write. So the public and private is only within the definition of your struct itself.
Yeah.
When you write the member functions outside, it doesn't matter.
Which is nice because you can change the visibility without moving it in two places. Just do it in one place.
So again, I want my nice big wall projector because it's come out tiny, I'm sorry. So we've got an example struct, it's got int I equals 0, public float f, public string, private string. And exactly the same thing. This time, I've just used the class keyword instead of the struct keyword. So I've created an instance of this first guy here. I try to access the member F. Well, that's in the public section, so we can look at it, we can change it, we can read it, write to it, just fine. However, str string, this is in the private section, so that's a compile error. Oh, sorry, yes.
Sorry. Because if everything in the struct defaults to public, then we just have to just highlight the private bit.
Absolutely, yes. Yeah, this public word here is completely unnecessary.
Okay, same with the class from the private. Yeah? You just have to change that. Because you know we got public. Okay. So,
Imagine the word public followed by a colon was at the top there.
Yeah, but with class it's private, isn't it?
Yes.
So we just have to really declare the public.
Yes.
Okay.
But once you've opened a public section, you then have to say the private things after that.
Yeah, but I would put the public last, so it's less work, you know.
Yeah.
So when you've initialized in the main struct example S,
Yes.
you have a private member in your struct example, so you would have needed a default constructor, wouldn't you?
Yes. Yeah. It's
Otherwise it
that's a
would
good
be
observation. But this is actually fine. So there's something a bit subtle going on here. So last week I was talking about aggregates, and I mentioned just in passing that something is an aggregate. It has two conditions. Well, more than that really, but two that we're worried about now. One is that it has no constructors, and secondly that it has only public members.
Yeah.
Right. Now in this case we have a private member, so this thing is not an aggregate.
Yes.
Okay, and yet I've default constructed it here. How has that happened? Well, it's because it's not an aggregate, and I haven't declared any constructors myself, so it does get a default constructor.
But in your slides, the way that you worded it was that if it's got a constructor and a private variable, so it has to add as there's the and rather than a private variable.
So,
private member.
So if it's got private members but no constructors, you do get a default constructor.
Right.
If you had written any constructors yourself, you don't get the compiler provided default constructor.
Too many rules.
Yeah.
So Sorry, is that in classes versus structs that happens?
Both.
Okay.
So no difference between class and struct, only the defaults. This rule applies to both of them equally because they're the same thing.
I was paying attention.
Yeah, no, I'm impressed.
But when you have a class, you could never have aggregate because it's private.
If I had a class and then immediately used the word public and all of my member variables were in the public section, that would be an aggregate. Because it only has public members.
Because I've all written that with public,
Yeah. So here, for those who can see, I know it's tiny, I'm sorry, I think this is probably the last tiny slide. So yes, we can access s.f, f is in the public section. We cannot access str because that's in the private section. s.I, that's fine because it doesn't have an access specifier yet. It's right at the top. But struct, everything defaults to public. So s.I is public, that's absolutely fine. Now we do the same again for our class example. Well, this time f, again, is in the public section, that's fine. str is in the private section, we cannot access it, that's a compile error. And this time, c.I, so this guy here, is private. Because by default, if we don't write an access specifier, everything in a class is private. So that's really the only meaningful difference between classes and structs in C++. Default member access.
So what's the implementation difference?
None.
So
The compiler...
you can just choose whether you like to call it a class or struct.
Yeah, absolutely, yeah.
Oh, really?
Yeah.
So why did they have two different things in this?
I predicted this question might come up, so so I actually looked it up. From what I can gather, so 1979, Jan Strostrup begins work on C with classes. So he takes the existing C language and he wants to put some object-oriented facilities in it. So C already existed. He started working on some language extensions called it C with classes. And from what I can gather, he introduced this new keyword class, and then all of this good stuff, constructors, public, private, protected members, inheritance, all of that, we're only going to apply to classes. Structs already existed in C, but C has no constructors. C only has aggregates, basically. Right? Only only public members, no constructors. Only has aggregates. So all the new stuff was only going to apply to classes, and then it sort of, as he was working on it, it emerged that actually, well, maybe it'd be useful if you could give structs private members. Oh, well, maybe it'd be useful if you could give structs constructors. Maybe it'd be useful if you could give structs member functions. All of that stuff. So in the end, it sort of emerged that, well, making structs and classes exactly the same thing, but just with slightly different defaults. That's, from what I can gather from reading online, I don't know if that's true. You'd have to ask the great man himself. But
It also aids backwards compatibility, right?
sorry?
It also aids backwards compatibility.
Well, yes, structs have to exist in C++
Right.
because we want to be compatible with C.
Bjarne gave a talk, I think it's one of the ones at CPPCon where he talks about this, and he specifically mentioned the reason for the class keyword in the first place was Simula. So he quite liked a programming language called Simula, which had this class concept, and that is what he started with. And then, as Tristan said, it evolved into sort of realising that actually they can be just effectively the same object with different defaults. So
you raised a good point. You said, basically, can I just use class or struct as I choose? What's the and the answer is yes. So perhaps we can ask, when should you use the class keyword and when should you use the struct keyword? As far as the language itself is concerned, it doesn't matter. You can do either, right? Just choose whichever one you like. Then there are no hard and fast rules, but generally we tend to use the word struct when something's very simple type. Something just probably when it has no private members or when it has no invariant that we're worried about. Classes, using the word class kind of implies that this type is a bit more heavyweight, a bit more complicated. So in general, we'd use the word struct for simple things and the word class for complicated things. But as I say, that's just a kind of
I can simplify it a bit maybe. This is obviously, again, it's a matter of taste, but usually I find that the best way to use them is a struct is something with everything public, and it might have some convenience functions in it, maybe even a convenience constructor, but it doesn't care what you do with any of its members, any of its fields, any of its data. I can freely just mess with them at any time, change them. And I may have convenience functions in there, but those convenience functions also shouldn't care what particular state any of that data is in.
no invariance.
Exactly, no invariance, but to put it in simpler terms. A class, on the other hand, should absolutely have an iron grip on its data. Everything should be private. It should only expose access to it through functions, which is useful because it means that if you need to change how you let people access your data, because they have to call your functions already, you just change what the function does.
So structs may be best used as like a database with like a lot of information in it, a lot of variables, and combine all those data to be one object. Can a class be like
I can see what you're getting at. Yeah.
the information?
I mean, they're really just to communicate meaning, though. At the end of the day, it's that if another programmer is going to look at your code and he sees struct, and it's an accepted idiom that, okay, it's using the word struct, so it doesn't matter what I do to any of the individual fields. Nice. Oh, it's a class. If something happened to be exposed, that's a bug to fix, right?
Yeah.
That's really what it's for communicating to other people.
So generally is because there's no set. That is your approach how you normally do it. So
That's
if-
my recommended approach. I have to do
Yeah.
it.
So someone you could write something using struct, and I can write the exact same thing using classes.
Yeah.
And we'll both be good because you're very comfortable with that. I'm very comfortable with classes.
But I would say the majority of code out there tends to use
Yeah.
that approach.
It's but it's sort of a convention rather than any
It's
sort of
convention.
rule.
You say potatoes.
Exactly.
But to amplify what Oliver said, right? If you use classes, then it means by definition that your private bits, your implementation, are private, and you have the freedom to change that as you see fit because the interface, which is public,
Yes.
remains the same.
Yes.
Can you
Yes.
enforce that with a struct as well?
You absolutely can. Of course. You can have a private section of a struct. You can have only private members and make people access them via public functions.
So it's just basically a matter of taste.
It's completely a matter of
It's
taste.
somewhat a matter of taste, but I would say one thing that should be a hard and fast rule is you can go your own way if you want, but be consistent. Don't just start doing random different things with one name in one place and then do a load of other crazy things in another place. It just makes it horribly confusing for anyone else, and probably you in 3 months' time when you come back and go, oh god, what have I done?
So I know, like, if I looked at your code, you do structs a certain way, and when you use class, it'd be easy for me to understand your code.
Yeah.
Because you've been consistent how you use struct and class.
Yeah.
It can make sense.
Okay, we have one last little thing to cover in this module, and then that's it. Very exciting. Well, that's the wrong button. Let's try this. Let's talk about friends. I know it's odd for C++ programmers to talk about friends because we don't normally have any. But this is all to do with public and private members as well. So normally, as we've seen, private members of our class are only accessible by other members of the class. That's what private means. That's why we want private variables. But occasionally, very occasionally, it can be useful to allow another function, a free function, that is a non-member function, to have access to a private variable. So very commonly, if you remember, whenever we write an output stream overload, we need to make it a free function, not a member function. But for debugging, we often want to be able to print out the value of our private variables, right? Just for debugging purposes. And when you do that, if it needs to access your private member variables, well, that's going to be a bit of a problem. How do we do it? And the answer is by using this keyword friend. Friend. Yes. What's that from? The In-Betweeners, yeah. Weird how that's caught on, isn't it? Probably like 10 years ago now. Anyway, yes, the C++ has this keyword friend. And the word friend can be used to grant access to private members of your class. So I lied and there is one. Oh no, it's not too small, sorry. So here, I've written a class friend example this time. So is I public or private here?
Right.
Private, absolutely, because classes default to private access. And I've put no access specifier in there, so I is private, and a clue there, this private member function, private function, is of course in the private section. And then I've declared that there is this function called friendfunc that takes a const reference to this class and returns an int. I've declared that this is a friend of mine. And because it's a friend of mine,
Go on.
You're allowed access to the closed group.
it's allowed access to private member variables.
Oh, you could say I consider it my friend. It doesn't mean it considers me my friend.
Yeah.
You can
What
consider
I'm
someone
trying
my friend.
really hard not to say is that friends can access your privates. Right? That's what I'm trying. I'm trying really hard not to say that. But
That's where this is going.
yeah,
So very good question.
yeah.
But that's already in the class, so why does it need that to be a friend? It's not outside.
No. This is not a member function. This is a free function. This is a doesn't belong to our
Put it
class.
in your class scope.
I've said this function. I could have defined this function up there. Perhaps that would have been a better example had I done that. We could have first defined this example, and then later said that it's a friend of ours.
Oh, so you have to define who your
No.
friends are inside your class.
You have to define who your friend. You have to declare who your friends are inside your class.
Right.
The definition of this function can live elsewhere, but you always have to define your friends inside the class.
So that basically violates that. All that's private, isn't it?
Violates it. It sort of punctures a hole in it, right? And you can only do that in very controlled circumstances. You can only do it inside the definition of the class itself. Yes.
Does that bring you to a global, not global scope, I guess? You still need to access it through friend example dot something. But it doesn't
Yes.
bring you to a global scope in a way.
Not really, no, because it's only inside the body of this, only inside the definition of this function are we allowed to access these things. Right. So I can give you a bit of an example. So we've created an instance of this friend example class. Again, we haven't written any constructors, so we get the default constructor. And then I've called this friend function, and I've passed it our instance f. So friendfunc is a free function. It's not a member function. So I don't say f dot friendfunc because it's not a member function. Right? It's just a standalone function, and I've passed it. We've said it takes. Sorry.
So the declaration of the function is missing.
Definition of the function.
The definition of the
Sorry,
function.
the definition.
The definition of the function hasn't appeared yet. It will in a moment. But I've called this. I called this function. I've passed it an instance of our class. And now we have the definition of friendfunc. So it's just a standalone function, as we've seen many, many times in the past in the course. Right? It's a function that takes a const reference to a friend example, and it returns an int. And inside the body of this function, I am allowed to call f.private function, because even though it's private, I've said this function is special and it is allowed to call private things. And is allowed to access f.I. This is allowed only because I've declared that this function is a friend of mine.
What's the difference between that and just putting public in?
Public would allow anybody to access it.
Only that function.
Friend says only the implementation of this function is allowed to access it. So if in main I tried to print f.I, it would say no, that's an error, you're not allowed to access this. But because I've said that this function is a friend,
Okay, right.
The definition scope can be either global or local. The definition only.
I'm not sure what you mean.
As in, like, you don't have to define it within the class. As you said, you can put it outside.
You don't have to define the function inside the class, no. But that's true for any member functions. You can always define them outside the class. But the friend declaration, that's this bit, has to be inside the class.
We don't have a friend example dot or something like that. We don't have to do that.
Sorry?
I don't want to sound like an idiot, so I'm trying to do it. So I don't have to do friend hyphen example dot and friend function.
Friend.
Because that thing belongs.
No. This function doesn't belong to the class. It's an external. It's external to the class. It's a free function, as we say. It's a non-member function, an ordinary standalone function. But it's special because it is allowed to access the private members of this class because we've declared that it's a friend.
And you have to declare that inside the.
Yeah. Friend declarations can only appear in the definition of the class.
Okay, that makes sense.
Is this coming up in the test?
I've no idea. I literally don't know what's in the text.
We'll find out too.
So-
Find out.
We look forward to it.
End of module test.
So this thing of having private member functions and having private member variables and controlling the access to them, it's often known as encapsulation or information hiding. Right? It's a way of controlling, maintaining the invariance of a class. And so this friend sort of functionality, in a sense, kind of feels like it's puncturing a hole in that. But it's really not. Because the only way to declare that a function is a friend is within our class definition. We can't, outside of this, declare anything to be a friend of this class. The only person who can decide who their friends are the class itself.
Elude me, what's the advantage of this rather than having a member function?
Good question. In case it didn't come out, what's the reason for this? What's the advantage of this rather than just making a member function? It's because sometimes you need to use a non-member function, and a really common example of that is printing things out. So if you remember when we wrote the overloads of operator dash dash, that has to be a non-member function, and so that would be a really common use case, perhaps probably the most common use case for writing a friend function. So you'd have friend, standard O stream, ref, operator, left, and then, yeah.
Would that be declared SD?
Sorry?
Where would that be declared?
Where would that be declared?
Most of the friend is in SD namespace.
So you would probably just write the declaration in there, and then you might write the definition.
No, for cout.
For cout. Well, if you write this sort of standard way of overriding this operator, that can be used by standard out because cout is a kind of O stream. So if you write it in general for O streams, it'll work for cout. It'll also work for file streams and string streams and other kinds of streams as well.
You go for the broad one, I guess. No?
Sorry?
So you go the broad thing.
Yeah.
The stream, and then you go that thing. Okay.
Yes, exactly that. It inherits from it. Yeah. So this is declaring a function to be our friend. We can also grant friendship to entire other classes. This has fewer uses, I think, than declaring a function to be a friend, but it's possible to declare an entire other class to be our friend. And if we do that, then every member function of that class can access private members.
That's going to be annoying. Yeah, but what kind of decisions would you make to say, like, okay, this thing should be, or may be, a candidate for being a friend, as opposed to an ass? Just basic.
Basically, friendship should not be, I have a bullet point on this, but basically friendship should be used rarely. With C++, we don't have many friends. It's, in a sense, it's sort of puncturing a hole in this encapsulation, in this private thing. So it should be used rarely, only when kind of absolutely necessary. And if you find that you're using this friend functionality a lot, it might be a design issue. Right, so legitimate cases, I've written a couple here. Logging, serialization. Serialization would be a really common example. So that's where we just want to write like a binary representation, a string representation of our class out to a file. That's would be a legitimate use case for friends, because we might have some serializer class that needs to operate, needs to be able to see our private members to write them out. So yeah, so serialization, debugging, logging, that kind of thing, those kind of almost ancillary to the purpose of our actual program. Those things are legitimate use cases for friends. So just to show you the syntax for declaring a friend class, you probably guess what it is, but just to show you, here I've written an imaginary serializer and deserializer. One is a struct, one is a class for no particularly good reason, just to use both words. And now our friend example, I've written friend struct serializer to say that this one is a friend of ours, or friend class deserializer. So this says the entire struct, all of the members of serializer are my friends, and all of the members of deserializer are my friends.
Because we need access to the attributes
Yes.
to save it as
Yes.
state. Yeah.
So if you had a sort of a private in serializer, can it use friend example?
No. You can,
So just to first of all clear this, it means that all of serializers, say member functions, if it had any, would be able to access all of the private things inside friend example. But friendship is only one way.
Yeah.
Just because I think you're my friend doesn't mean that you think I'm your friend.
Kind of like Facebook.
Exactly.
possibly a slightly more memorable way that I remembered it was that just because I've said you can touch my privates doesn't mean you'll let me touch your private.
And that's the last time you were here. Friendship is only one way. Right? This, just because I've said that serializer is a friend of friend example, doesn't mean that any member functions here can access things inside serializer, because otherwise that would be a way of violating this encapsulation. Because serializer wouldn't expect, the author of serializer wouldn't expect that anybody else can go and mess about with their internal state. So friendship only works one way.
But private member functions serializer can use friend example.
Yes, because inside friend example, we've said this whole class is a friend of ours.
Daft question. The friend keyword is only valid within a class declaration.
Correct. Correct. Yep.
And makes no sense. It's probably, is it even valid inside a struct?
Yeah, absolutely. Anything you can do inside a class, you can do inside a struct.
Right.
Absolutely.
It doesn't make any sense inside a struct, right?
Well, it does if the struct has private members. There's nothing to have stop a struct having private
That's
members.
true. Right, very good.
Yeah. And I've already said this, but just to reiterate, friendship's something you should do rarely.
It's opposite of life.
In C++.
Wary.
Yeah. All sorts of just, very inappropriate jokes you could make at this point. But yes, overuse of the friend keyword is probably a sign of a design issue. If you find that you are often having to grant friendship to other functions, to other classes, it may be that you have to rethink your design. Perhaps you should add some public member functions, because obviously there are other classes that need access to something that you're not giving them. So rather than doing it on a case-by-case basis, you would have a new public member function and say, okay, well, actually anybody is allowed to read this thing.
So again, generally, if you have a friendship, you should see, can I do this another way?
Yes, yeah. Apart from very limited cases such as writing a print function or writing a serializer. Those are sort of special cases, but
Sorry,
if you find yourself doing this all over the place, it may be a design thing, yeah.
in your code, how many friends have you No, so how many friends have you made?
How many friends have I made? As I say, it's something that is done rarely. And it's
Friends with benefits, mate.
It's mainly used with the operator keyword. In most.
that
cases.
would be a very common use for it. Yeah.
I mean, in sort of, if you were just like pick any random thing on GitHub, if you say, well, where do you use friend, you'd probably see it next to the use of the operator keyword.
I can give you one concrete example that I had to do. I had a design for doing TLS connections, okay? So SSL, TLS, same thing. And I had a class to represent the handshake state. And then I obviously wanted to then transition to a class representing the established state, which would just exchange data. So that was the one case where I used a friend, because what I wanted to do effectively was to struct the handshake state, but take the connection out of it. So then the active session state was a friend of the handshake, so that once the handshake was done, that would get constructed, take the connection.
So you've not made any friends out of it?
No, absolutely not.
As you mentioned before, like about logging, I'm imagining like if you had another programming language that wanted to access some output that you were getting from C++, would that be a way maybe to use? No, maybe I'm thinking of a complete tangent actually.
I would say in that case it would generally be better to have like public access to functions.
Yeah, you would just pick it up from
And that's it. That's module 2. Yes! Yay! Oh.
Go on, man.
All right. So we do have some fun to come, but we've got a little while yet. So I did prepare a little exercise for you. In fact, I won't lie to you, I prepared it quite a while ago. But I reckon I'll give you 20 minutes to work on this if you'd like to. So at past, we'll commence on our little questionnaire. But if you want to go to that URL, so the people who've been here many times will probably be used to this rigmarole.
So last time that wasn't enough, so we need to have a bit more so we can all try to finish it.
Yeah, so I think the best thing to do is have a go at the exercise, and also obviously if you're planning to do the test, everyone's welcome to do it. It doesn't matter if you fail or what. We're not in grade school. Revise a bit as well if you need to. So use this 20 minutes to do the exercise and or revise as you personally need.
I'm just gonna go to the toilet break.
Oh, you can just spend 20 minutes on the loo. I mean, that's
Okay, then now we're all friends.
I am-
Much information.
He's broken down his friendship.
This is just the URL that is given by GitHub. I'm going to copy and paste it into the Slack channel now
I'll put it on YouTube
for anybody who I can see that a couple of people have cloned it already. So I'm just going to copy and paste this into the Slack channel, which be a bit easier.
You pasted it? Oh, you pasted it. Right, it's in our YouTube chat on the live stream, so you can grab it from either the Slack or from YouTube.
That's the bit at the end is 575, capital I, lower L, lower C, capital B, capital A. As always, if you've got any problems, ask Justin, because me and Ollie are leaving.
Do you the test bar, is that on a computer?
It's on Google Forms, so if you've got a phone, you can probably do it on your phone.
Okay.
I mean, there might be bits that involve writing code. So I don't prepare the test. Ollie prepares the test, so I literally have no idea what's in it.
All right, cool.
So it's a bit like I'm the teacher and he's the exam board,
Excellent.
and I hope that that I've taught the things he's examining
My laptop's still busting. That's
a bit. But I have drunk too much water, unfortunately, so I'm going to have to.
think there's a student HPP. Let's see that. No, if we're say there's a student HPP.
There's no student HPP. Maybe it's an example.
Yeah. Fine.
Maybe it's just a rename.
Okay, maybe it's just a
Yeah. This is naming the issue or
Yeah.
maybe. Is
the
it?
example HPP is actually the student.
Struct. Just wanted to make sure that something is inside the example HPP. The student is inside as a struct. So if you click on header, then struct.
You have the right thing.
That's what you mean.
There's one with Harry Potter in the name.
We should.
The one in the mail?
Harry Potter.
Wrong with what, yeah.
Thank you, fair. Alright, how's everyone getting on? No troublesome sound assignments?
Who was new today? We had lots of new people. You've been to one before.
It wasn't actually the class, the other, the one
The workshop.
Thursdays, yeah.
Okay. We didn't mention the workshop.
Do it at the end. I'll do it at the end. That way it's fresh in your mind as you leave.
That was really good though, thank you. Like first coming I was like, there was so much I was deeply learning about like structs and things I didn't realise.
So, have you used C++ before?
Yeah, I studied computing at Goldsmiths and they teach C++ in so I've had like a couple of years experience but not very
You should probably know the front end.
not like not a computer science degree, it's kind of creative computing so they don't go so deep into unless you want to go into that.
Yeah.
But yeah, I don't know. There's a lot of things I still learn a lot from just this kind of stuff, so it's nice.
How did you guys find us, by the way, those of you who are new? I'm just curious.
Recommended by a friend.
By a friend. Excellent, okay.
It's actually good.
How did you find us?
Found about it. Code notes.
Yeah,
for
code
ABC.
notes.
Code Node, okay, yeah.
Yeah, because I used to come around for ABC Jews meetups, so knowing a lot of things.
Just took on their website, yeah.
Yeah.
Okay.
So yeah, if you have any problems with the exercises, if anything doesn't make sense,
Please do ask for help.
raise your hand. We'll try and make our way to you.
Need like a system of police, like, you know, reach yourself around.
I get an email every time somebody clones this repository, so
Yeah, so do I.
I can see lots of you have managed to do it already, so that's good.
Well.
Managed to clone it, not managed to do it.
It used to be much worse.
There's a difference.
We used to have the classroom on our main organisation, and we just got spammed with other people's
Yeah, it's
repos
really
in there. We learned from that very quickly.
So the short is fast.
I think the stuff's going to take more than 10 minutes to do.
Well, I sort of anticipated this might happen. This would become the whole work.
Do you often end up writing your functions in your header file and then just cutting and pasting across to your CPP file and then just putting a semicolon on the end and then
Yeah, in fact, I believe C-Line has a you can like right click on it. And,
does it? Okay.
yeah, it's like one of the refactor options. Is
Yeah.
to,
Sometimes it pops up with that little light bulb saying explain to definition declaration.
Oh, okay, right.
Of course, if you watch my TDD videos, you see that I do that as I write the test and then eventually break them out.
Oh, yes, you probably did.
Yeah.
I watched the
But then you
first
still
one.
have to
I
copy
did.
and
I
paste.
copied the first one as well. Sorry.
And that's a matter of taste. It's not right. I'm not saying it's the right or wrong way. That's just purely what you fancy. I just find it more convenient because there's not enough code. It saves me switching files.
Yeah, exactly.
Alright, so yeah, so I'll put the slides on here, and then the quiz thing, the URL. I don't know how long are you going to leave it open for.
I can reopen it for you if you message me on Slack.
Yeah, okay.
If you message me on Slack,
Yeah, I'll just do that.
Yeah, it's awesome. Thank you for coming.
I'll see you soon. It's just
No problem. Sorry. Okay, so what did I ask you to do again? Constructors think first, last, and ID variables. Some of these classes have variables. Does it remember initialize this? Okay, so this is something we were talking about last week. Right?
These two functions.
So were you here last week?
No.
Ah, okay. So you have to. So that's constructor. That's fine. Name,
Oh,
ID. I like it. Okay, so now you need to use a member initializer.
Yeah.
So, if you want to know what that is, probably the easiest way, quicker than me explaining how, is just have a look at the slides from last week. So I explain it now. So, you go to, just look at the new tab.
So if you want to do it on the screen,
So,
yeah.
oh wow, let's announce this.
So that takes an
I
hour.
want to just control
So
C.
you would the left hand side
Yeah, I see. So go to github.com.
and okay. And so here I should do
CPP overview.
this will be yeah, cool, cheers, thank you. And so
No, just not without the classroom.
because that is the name,
That's
and this is the type, the value.
Okay.
So if you put the and on the type,
And then
that would
Go
make
to
this.
this one.
Oh, okay. That's the only way you can put on the name.
Yeah, that's it.
On the left hand side, to get the address.
Oh, okay.
So what should I do now? Should I click on the and?
Oh, right.
So
you've got a mouse in there.
Oh, okay.
Okay, so then if you have a look at section 4.
Oh, okay. Yeah. Yeah. Okay, so now here I can actually. Yeah. Yes, the idea is to still make
Yes, I got some. But I like the one with the orange one, you know, the orange one. They hardly happen though.
So
Member initializers, there you go.
name
Must be
and
some
then okay, cool. Yeah, it was just a friend that should pull
It's a strange thing for C++ writing this control.
so
When you say access a function,
I mean, so I told you to do it by the get first name function.
oh, this is set
Access is get access is the first name variable.
yeah.
So I want you to write similar like get last name and get ID.
Oh, okay. Okay.
yeah, to get the name
And also equivalent set functions.
and to set the
Okay,
name.
so set last name, set
Yeah.
ID.
Yeah. And your set last name should enforce the invariant that we have an initial capital followed by also as that it's always lowercase. I want you to write a student class that has the invariant that the first name and last name have always an initial capital followed by lowercase. It's completely non-unit variable.
Yeah.
Yes.
Yeah.
Okay, so that's
Okay, so that here. Yeah. Oh,
So I wanted you to use a member initializer. No, it's the same beginning there. Okay, so in C++, you don't have to say this. In fact, you can't say this. You have to say this followed by an arrow.
Yeah.
But you don't even have to say that. You just say
5 minutes, folks. 5 minutes.
Yeah. So if I do
But that's not going to work because it's going to think the first name is referring to this name. So that's not going to work. So what you need to do is
memory now.
it's probably easiest if you just have a slide.
So I do something like this. Right.
Session 4.
Okay.
Yeah, that's really annoying.
Well, I should,
Sorry.
I should set
So if you scroll right down, talk about member up a bit. Starts the section and member initializers. And it's this thing that you saw it in the LCString
yeah,
class,
because
it's where you write the colon followed by the members.
So
So explicit constructors was today. I prepared it last week and just didn't have time.
It doesn't matter. Not that. Okay. In private here, for example, the private is takes action until the
Again, it's a matter of style. It really doesn't matter. The language doesn't. Some style guides, yeah, they capitalise classes. Others don't. So Boost, for example, is a very common set of C++ libraries, and they make all the type names work. And I tend to follow that sometimes, and then other times I do it Java style and write my class names with capital letter.
I tend to aim to distinguish, if I'm writing an application that needs not a library, I prefer to use some style consistently that distinguishes my classes and stuff from any of the libraries I might be using. So I explicitly don't want it to look like a Boost or look like the standard library because I want to know it's mine.
What namespaces?
Oh.
Sorry.
Using namespace to be that way people do it.
Yeah, don't do that.
So I should do.
Hey. Oh. Is that yours?
Show me that. Has it got my
No, I
class
think it
written on
was No, it's
What's written at the bottom?
chap who was set here.
No, the bottom, the other side. There's an imprint. There's an imprint in the.
Yeah, no, I think it's his. It's fine.
Oh, okay.
I've just stolen his seat.
In terms of set first name,
Okay.
do you want to make sure the first name is capital?
That would be, yeah. So what I wanted you to do in this case was to do you remember how for the LCString class, I used the member initializer list? So in the definition of your constructor, you write colon, then the member names. Yeah. So that was just specifically I wanted you to practice using the member initializer list. So that's
What would I do here?
so in between the closing thing and the opening, so in there, so just one character. Yeah. Yeah. So it's probably easy to put it on a new line.
So I'm quite you mean
So I meant put the colon on a new line as well.
It just basically means when you return.
So then, between the colon and the opening little curly brace, you need to initialize your member variables. So we initialize our first name, member, with first. So do first name and then. You can't use equals, you have to use brackets.
Has anyone completed it yet?
Oh, okay.
So that says when you create the first name variable, initialize it.
Or any of the exercises?
I've done the first two.
Is that a comma that's separate?
And then a comma, yeah.
Can I do
That's after making a tea, going to the toilet, having a cookie. That's after going to the toilet, making tea, having a cookie, taking my time to read
Is it
it.
actually last? That's last
It's
name.
last, the member variable is called last name. Yeah.
Okay, let's
1 minute.
Oh yeah. So these should be because it was
So in terms of the invariance bracket, I'm sure this is always the first thing up and on.
Exactly, yeah. So you can do that in the body of your constructor,
okay, so
Okay.
as I did for LCString.
Which had LCString up, so I can do it here now, yeah?
In the body, yeah. So you don't need those 3 lines because you.
Yeah, so I've done that there.
Yeah.
Did you do number 2?
That's neat. How did you do that?
I haven't been doing
No, that works.
It seems pretty straightforward exactly.
So you'd probably, well, first of all, you've got to make sure, it's a little bit tricky, so you've got to make sure that the string has at least 1 letter,
I mean just like
and then you've got to change that first letter to a capital, and then you've got to change all the other letters after the first.
I don't know anything about
JavaScript might be
okay.
How would you do it in JavaScript?
I would do first. Slice the first 2, slice one from 0 to 1, just give the first one, do that 2 upright, and then I'll just go slice 1 and capture the rest of it. I'm just going to concatenate together, that's really cool. It's not that easy.
Yeah.
What would I do for this one? Because do I put the body of this thing in here? And what it does?
So, what you might want to do is to write a private function that is called like initial characters. That would do this for any that you can reuse in your set first name function as well. So, like I did with that.
I see.
So,
Okay.
we can write it in the body of the constructor to start with. You can just do like first name,
And then
Another part.
and then and then you can use this square brackets to say. So we count from 0 in C++.
You don't need to because it's part
So
of it.
first name square bracket 0 will give you the first character. So call 2 up. So to do that, no, you can't do 2 up. To do this
What does it mean
equals.
accessor functions? The
I know
same
what you mean
thing.
about
The
my
same
Add
thing.
a function and let someone call it in order to get the
By the term, I know how when I do it and it'll work. So I don't know what you want to
Oh,
Yeah, this
I can
number.
primary should be primary, right? So you need to make a function that
Yes,
gets
I'll probably do this.
Yeah.
Today.
Yeah.
So I'm not complaining about. So what this is saying is, take the character 0, the first name, pass it to the 2 upper function, and whatever this returns, I'm going to assign it to there.
This variable
Yeah.
stored in X, go and get it.
Well, we haven't made sure that all the rest of the characters are lowercase. Also, there's a little bit of a danger here, because what if somebody gave us an empty string?
Okay, JavaScript, I just do two bracket, two. You know, the all
That tree's gonna die soon.
What,
So
that's a string.
Yeah, so
okay.
probably the easiest way of doing it is just to like if first name dot empty return. That's just so if first name is empty, we do nothing. We just return. But I've given you 3 minutes longer than we said we were going to. Not really time enough to get the whole exercise out of the way. I did sort of think that would happen. So if you want to continue that over the coming week, also if you will, I'll mention it again at the end, we have these workshop sessions on Thursdays. For those who don't know, everybody's welcome to come along. We're here. Is it here?
If we're not here, we're literally on the opposite side of the road in Costa, so it's here either way really. Just, you know, physically come to this bit.
Well, this week's meant to be here.
But yeah, I believe we should be here in
I
Codon.
registered on the skills
Then we are. If you registered, we are. So we are here in Codon on Thursday for the workshop. It's an informal session where you can show up, do the exercises we have, or just bring along a C++ project if you wish. Right, so on to the test. Obviously, it's for you to gauge how well you're doing, so obviously don't just guess at questions. If you don't know the answer, just leave it blank. It helps us to make sure that we're teaching you as well as you obviously learning effectively from us. So there's the URL. It's also pasted on our Slack channel as of, not right now because my clipboard has cleared itself. That's really helpful. Right, so it will be in the Slack in a second, or you can just copy it off the screen. Where are we? There we go. Okay, it's in the Slack, and it's also now on the YouTube channel as well.
So for those who haven't done these before, what happens is that you submit it, Ollie will mark them, he'll give you your marks back by email, and then at the start of next week's session we'll go over the responses, the answers.
The answers, yeah. If you just go on the Slack, it's there. No, ISO.
Yeah.
ISO. It's the international date format, year, month, date.
Okay.
Or just, if you use international, it doesn't confuse anyone because Americans do month, date, year. We do date, month, year. So the international format is just doing year.
Sorry, Ollie.
Yeah.
Can we really answer number question number 2?
Can you what?
Can we answer question number 2?
What do you mean, can you answer?
No, it's not encrypted. No, you got protected. That's what I'm saying. That's what I'm just.
I'm not entirely sure what your question is. What's your question?
It says a friend is able to access the private or protected things of a friend creator, and also probably evidently that's probably not it.
Oh right, yeah.
If you click the, does it not? Does it cut the text off?
I think what he means is I didn't say anything about the protected, so I didn't mention whether.
I mean, it doesn't. Don't worry about. Yeah, he didn't mention protected, but there's no. I mean, there's nothing in there that doesn't mention protected anymore. So logically, right?
Okay.
It's got to be. Yeah.
That thing worked, but I don't know. I didn't test it. So, is the test already included, or should I write a test to see if it works? I'm not talking about the test. I'm more talking about the.
Is there a test for that exercise?
Or we have to taste if it's right or wrong.
I don't think I wrote any tests for that.
Oh,
You have
so
to do it.
then I'll okay, test.
Oh, yeah, I'll see what to do. Open an incognito. No, click this. Paste. Actual view. Do I do that really? Try going, just, okay, don't do it from here, just go back. Just paste it.
No. This is good. Further ahead now.
When you mention overloading the assignment operator.
Which one's which question?
It's interesting about the overloaded with assign.
Well, I just went with comment.
Well, I didn't mention implementing.
Needed a comparison. Okay, we'll see if we can use the logical reduction case. That really kicks in the later questions. This is module 2.
Well, that's what happened.
It's quite difficult.
Custom types.
You should go and rename videos. Something I didn't mention, if it's multiple choice, don't guess at it. If it's one that requires you to just write some code and there's an empty box, then you think you have at least an idea, then feel free to fill that in anyway. Don't guess a multiple choice because you have a probability of getting it right anyway. Minutes.
Doing this on the phone is quite tricky. Especially with 2% left.
Better hurry up.
Going for the extra challenge there. Handicap. We have one person completed. But so base name just they just answer some of the multiple choice.
Define as a non-member one. Constructor. Define as a non-member. That's right. That's a two.
No, I'll take one off because that's it.
Pushing you to drink, is it?
No, it's good.
Not bad.
Being the pressure sent,
You've already got one of the essential skills of a C++ programmer. That's coding with one hand and drinking with the other.
Responses and that's not the other one. The source didn't do anything yet because it wasn't the bulk.
These lines.
You don't have to.
Yes, you did. And that's really the
Oh, yes,
structure-
yes, sorry.
structure
That's right.
actually
Yeah.
Is the
by default. Nasty, but if you have anything for price.
That's not really.
Anything for well, I think it's because you use a class, right, and it's just a stupid wrapper, it's going to run some stuff. And then it can throw in the
because
district.
here it says there are first.
You have to actually let it run.
Right, something you get it
Yeah.
cheaper.
Well, it says prices are
I think I can see that. See that.
Okay, ladies and gents, 5 more minutes. I do really feel like I'm at a school exam now. Anybody needs more paper, raise your hand.
You need to send them out the tool.
It's true.
Excellent.
Yeah.
So this is a bit mad. Yeah. I've always wanted to learn like community-based learning. You know, like we work on a project together. Like,
Yeah.
how do you know what doing it?
So you want like for C++?
I don't really care, man. C++, Java, whatever. Let me be humble and do C++.
Like some sort of project where you all kind of work together on it. I don't know of anything off the top of my head. I know there's something Giacomo does on Saturdays.
Oh, the JavaScript group. It's in a hotel.
I know there's a group. Some of them have come here occasionally, and they
Code Academy, yeah, just
Code Academy. Yeah,
You know as well?
they.
No endorsement there.
I know they meet at some hotel in the city.
Yeah, it's the Whitechapel thing, isn't it?
Sorry,
Is it not the Whitechapel one?
I don't know. Yeah.
Citizen M.
So Code Academy is what they call it. And they meet up and they work on JavaScript. But I've never been like JavaScript's my thing, so I've never been. I don't actually know what they do at these sessions.
I've been doing JavaScript for a couple of months.
Lots of right answers. Screwed up the default constructor.
So I've been doing it for a little while. So I went on Cold War. Didn't I?
Oh yeah.
I think the best thing about Cold War is seeing other people's code. I've been doing it since.
Which line is
I've only done the simple ones. I've been doing it since.
Don't say it, point to it.
I've been doing it since March. And I've managed to knock out 1,038 of these suckers. Yeah, I've just been kidding. That's what I'm saying. So
I've had it on my phone.
So you'll see stuff.
Yeah,
You see, the thing I like about it is
Point it out.
Yeah.
It's only a warning.
so you sometimes get discouraged. Like, what the hell is this, man? What's the purpose of what I'm doing?
Yeah.
So I think, because I never did those tricks for this, I think it's a good tool. So these are the 7 because it goes in right from 8 to 1.
Yeah.
So I do a lot of
So is that like difficult?
Yeah, I do a lot of ones, a lot of stuff.
See,
It's not 6.
I can give you that.
The thing about if I do this now, so this is
Oh, okay. So it's a bit like the.
but it's not as hard as have you tried HackerRank?
Yeah.
Yes.
Some of them are. Yeah.
I think you need to be updated to do that. But this is more like the thing I love about this is when you go to a session, still work. I think this is the best thing about it. You get to see other people's code.
Oh, right. That is
Get
good.
to create your solution.
It's missing
So
out.
there's
What
my
you're saying is technically true.
Yours
because
actually
it's
looks
the bug should be fixed.
Yeah,
The bug
because
should be fixed here.
when you read the thing, it makes sense to set up a map in it. Well, this is an object, the same thing as a map, and then go through it.
No,
using
if
it.
it's default
Then you see,
constructed,
I've got other
if it's
things
default
like that.
constructed, it should not call it.
And I'm like, oh my days, I'm days.
That's what I'm saying. That's the
Their
bug.
code is like this. Mine is
But
like
it's nothing
this.
to do with it.
Yeah.
I think it's a good way of looking back at
No,
it.
it should
Yeah,
have
definitely.
checked this.
If you've never done JavaScript, because I've only
So Code Wars is
That's
only
not
JavaScript.
that's the thing it's supposed to do.
when you do, because they have these
It's
kata
not,
things,
it's
in
not
there,
the structure's fault.
you actually
that
get
this
more
is
points if you
screwed up.
design the kata. If you work in collaboration.
Okay.
The top boy's got like 122,000, I've got like 3,000.
And what it would do
So
is it was
these are the
this
languages,
was
and they can go by language. What language you want to go by?
So look at C++ for us. Because this might be a good thing for like me to recommend to people who want to practice.
Let's go for it first.
So V8 is really hard.
No, they're the really easy ones.
Okay.
So
Hence I think that's
the purpose of it was for this to then mark
Yeah,
it
so
as like you don't have to do it. So if this was
Oh, they were there, yeah, because these I've seen.
set this,
So do I have to do
if this was implemented correctly, you would set this variable and then define. So it's supposed to, it's
Well,
supposed
you
to
can
check this.
just choose the language.
No, you should get moved from. If you get moved from,
Okay,
you
this
move
actually
from.
looks like it would be really good for like people to practice. You know, we have, I don't know if you've been to any, but we have these Thursday evening workshop things. This actually looks like it would be really good because, like you say, with HackerRank, some of them are really hard. They're really sort of.
I went to HackerRank as well.
So it means it calls it.
You see
Which will crash, which is wrong.
I just got discouraged. When you do your code in Java, it just looks way, way longer.
Yeah. So I went through HackerRank and I did like the easy ones in like really quickly, and then suddenly you just dumped on something that you have to really think
Do
about.
you know what I realised as well? It just showed me I had a hole in my learning in terms of computer science.
Yeah, it is very computer sciencey, and you've got to think very carefully about algorithms and everything.
No, it's a comment you could state.
Okie dokie, it is 9 o'clock, and your time is up,
The point of this comment was to tell you.
ladies and gents. Are you going to? How many responses have you got?
Right, I currently see 8, but I will refresh and see how many.
I need more time.
We still have 8 responses.
Who has
9
not?
responses.
Who has not yet responded?
I need some time.
Gonna have to call a close to it, I'm afraid, because it is home time.
I'll let
pub
those
time.
of you who's got most of it done. Okay, if you wish to have another crack of the whip at it, like with more time, then I'll allow that. But please submit now so we can see how you do under time constraints.
Alright, but that is the end of the session, that is the end of the module. So, next week we start again with a whole new topic. We're going to talk about containers, iterators, the STL, algorithms, all that lovely stuff, all the really, really good stuff that's in the C++ standard library.
STL being the standard library of C++ for those who are new.
Yes. So that's going to be our next module. Beginning next week. For the coming week, if you want to finish off that exercise that we started but didn't have a lot of time for, that'd be awesome. And otherwise, oh yes, and I did mention it, but on Thursday, so this is only half of what we do. The other half is on Thursday evenings. We have workshop sessions, so it's not me talking or anything like that. It's purely a practice session for you guys to get together and work on problems. And we always have people there, usually Ollie.
It's very informal, just show up.
Yeah, just turn up.
Yeah.
Don't have to do anything, bring your laptop.
Yeah.
Yes, and now, as Tom likes to say every week, we're going to pub.
Yes.
So everybody's welcome to join us. It would be awesome, particularly the new guys. You don't have to, of course. It's completely optional. But if you'd like to, it'd be great to see you.
And if you like what we do, feel free to buy, preferably him first, but any of us a bit.
Right. Thank you very much. Apologies that we're in this cramped little room today, and we've had the tiny TV.
I submitted.